So first of all, welcome to Las Vegas, and thank you for spending a little bit of your Sunday afternoon with us. We have some really wonderful material to share with you today. First, a couple of provisos. Presentation may contain things that may not come to fruition. Most of what I'm talking about today, though, is real stuff that you can do right now. So I am Jonathan Butz, healthcare business strategist with VMware. I'm in my 6th year at VMware, and before that I was in the partner space, so I'm going on 11 years in and around VMware and all of the other things that touch it, the storage, networking, and higher up in the Microsoft stack. And I've been covering healthcare now for 2.5 years, and I want to say I've found a bit of a purpose covering healthcare and serving healthcare, because the outcome of the work that we do in healthcare is properly meaningful. We're not just looking for new ways to sell products and more efficient ways to get to market. We actually have a noble outcome from the work that we do, and I'm deriving a great deal of satisfaction from that. So our time today, I'm going to give you a little bit of an update on where we are with Epic and what you can do with our software-defined platform today. First of all, how many people in here are running Epic? Okay. And for those of you who are not, I assume you're here just to hear about the software-defined story, which will still be relevant. Most of what I'm talking about today is relevant regardless of the platform that you're running, but I want to give you an update on where we are and what you can do today. And then I want to spend some time focusing on the rationale for this hyperconverged platform transformation, this transition from hardware-defined solutions to software-defined solutions, and what that means for all of us. And then get into some of the details of the platform value, because this is something that is absolutely necessary for all of you to gain the support of your leadership in this massive transformation, to unlock the value of your on-premise infrastructure. And then we'll spend a little bit of time talking about Lancaster General in particular, the highlights of what they've done and what they've gotten out of it. And I know originally in the program bill, Brian Grimm from Lancaster General was going to be here on stage with me. Unfortunately, that was not possible. But I decided to run with this regardless, because this content is too important to ignore. So really quickly, where we are with Epic. Epic has recently updated their storage products and technology status document to include specific language for hyperconverged and in general, and specifically with regard to vSAN. And basically what we're talking about now is being able to do Hyperspace delivery and the web server service tier workloads on vSAN today, right now. They're recommending against the operational and analytics databases, and mostly because that testing has not yet been done. And we have a very close partnership with Epic. We work very closely with them, and it is my hope that we will successfully complete the validation of our platform to run the more intensive workloads. And I look forward to being able to tell you about those when they happen. A couple other sessions that, if you want to take a screenshot of this slide before I move off of it, we've got a session on Monday, Hyperconverged panel discussion, which Michael Feld is going to participate in. He's the Renta CTO at Bay States and was at Lancaster General when they embarked on the software-defined journey, and he's down here if you'd like to meet him for a Q&A at the end. And then on Tuesday, we're going to have Michael Feld directly in a group discussion to talk about doing more with less in his role as owner of Vertitech IT, and the reasons that he sees healthcare embarking on this software-defined platform transformation. And then on Wednesday, we're going to hear from the Bay States folks directly on their quite compelling, quite advanced 3-site high availability configuration, leveraging all of the things that we're going to talk about today. So just very quickly, talking at a very high level in very simple terms about what we can do on vSAN today for those of you running Epic. We can do, as I mentioned earlier, I think I've got a pointer there. As I mentioned earlier, we can do the Hyperspace client delivery running on vSAN, and that's regardless of the solution that you choose. It doesn't have to be ours. But if you are still doing hyperspace delivery, leveraging shared storage, I strongly encourage you to look at the alternatives because we can make it scale better, perform better, and cost substantially less. This is, without a doubt, a necessary analysis if you're still doing hyperspace delivery on shared storage. And then the web and server service tier workloads, obviously, you know, they don't really care what the shared storage is. And then you know, for the operational and analytics databases, the cache and clarity databases, you can virtualize them on Red Hat for cache, sitting on vSphere, but generally Epic's guidance is still to use shared flash storage for those components. And again, I hope one day to be able to tell you that we have another option for you to examine, but we're not there today. So I mentioned earlier about the noble outcomes of healthcare, and I think it's important, I think, for us as technology professionals to take a step back once in a while and consider the outcomes of the platform that we deliver. We as technology professionals in healthcare are responsible for care, and there are many layers between what we deliver and what the healthcare system as a whole actually delivers, which is patient care. So I think it's good to talk a little bit about the role that the platform plays in the delivery of care. So without a doubt, the healthcare industry as a whole is focused on the successful outcomes of the delivery of care and the satisfaction of patients. This is something we can all get behind. And there's a good body of data that shows a very strong correlation between the successful outcomes of care and the satisfaction of patients and the satisfaction of physicians and clinicians. So, want happy, healthy patients, need happy doctors. Doctors today, more so than any other time, are completely reliant on applications to do their work today. And we know this is true for those of you who've lived through outages. When applications are not available for whatever reason, care suffers, and we resort to very complex mechanisms to continue to operate in lieu of those applications. So in order to have happy physicians, we need applications that are highly performant and highly available. And that requires that the platform on which those applications run is highly performant and highly reliable. And at the same time, we have to address external forces on the healthcare industry as a whole, forces that are causing us to consider greater security models, better security models, because the healthcare overall has become a greater target than any other industry for organized theft of records. And we need to address the challenges of the ever-increasing costs of healthcare. Customers come to us all the time after investing in a new EMR. You know, when the new EMR is deployed, the budgets are open, and there's access to capital and operating dollars in plenty. But what I hear from many customers who are coming up on that hardware refresh of that gear after having gone live on a new EMR three or 4 years later are asking us to find ways to help them reduce the total cost of that infrastructure. It's a universal theme. So I would like to take a couple minutes and just talk about why platforms have ever been chosen. And this is not just true in healthcare, but it's especially acutely felt in healthcare because of these external cost pressures that I've been mentioning. If we look back at the history of technology, these are what I would consider to be some major epochs of technology stacks, beginning back to the mainframe. And what I set out to do when I put this together is I was looking for the themes that drove the adoption of each of these platforms in their day. And the theme that I found throughout that was consistent was value. The mainframe was a huge multi-million-dollar investment, the like of which companies had never purchased before. And there had to be an outcome of it. There was a positive ROI on that investment in terms of increased productivity for the most part. And that continued on, unrivaled for a time, until the rise of x86 compute and Microsoft and Linux operating systems that gave us an alternative and caused an explosion in application proliferation in all industries. Again, driven by the value. It offered a lower total cost per application than the previous platform, which led to its massive adoption and led to the technology pains associated with that x86 server sprawl. And for those of us who've been in this industry more than 15 years, we remember those days quite well. So enter virtualization as a concept. And what drove virtualization is funny. I ask people a lot, why did you virtualize in the first place? It's been so long since we did it. It's important to ask that question again. Why did we do it? I hear a lot of the time, the most popular answer I hear is it's easier to manage. That's true, but it's not the best answer. The real reason we adopted virtualization in the first place was because it offered a lower total cost of operation per application, period. You remember we did that. We collected data on all your x86 sprawl, and we said, listen, if you buy a SAN and you buy VMware, we're going to knock 30 to 40% off the total cost of running your infrastructure over the next 3 years. Sometimes it was even more profound, right? We're here again with a similar value proposition in the advent of the software-defined data center, fueled primarily by the savings afforded us through software-defined storage. And here's what it looks like. On the left, this is 3-year capital cost. And I'm excluding operating, because the operational savings are profound too, but they're harder to defend and they're harder to calculate. This is easy, because this is money that's going to be spent on one thing or another. So on the left, the traditional stack, all flash, shared storage, blade-based compute, and our software suite. On the right is the software-defined data center model using flash-based integrated flash nodes and our suite and NSX and VSAN. And what you should note here is we're talking about a substantial reduction in capital cost, but we're also talking about the addition of new capabilities. Particularly relevant to healthcare is the advent of microsegmentation, the ability to dramatically reduce the attack surface of our x86 operating systems through software-defined security policy. So this is what we're all running today, for the most part. And when I talk to executives about the need to transform the platform and implement some of these newer technologies, I find that executives very often don't have a great appreciation for the complexity of the current infrastructure stack. And this I think illustrates it quite well. And if you want to use these materials in the future, I'd be happy to share them with you, because I think they're delivering compelling results when I use them. Where things break is where they interconnect and require different skills and different interfaces to manage. And remember, all this platform does, all these moving parts come together to run applications. That's all it's for. And unfortunately, it's not like this is not like any of us did anything wrong building this platform. This was the only way to build it. The very nature of virtualization required shared storage in order to do this, which led to all of these components as they are today. The challenge with this, of course, as you all, I'm sure, have experienced, is when things go wrong, this is very difficult to troubleshoot because we need half a dozen different guys with half a dozen different interfaces and half a dozen different skill sets. When we scale it out, these different components scale differently than one another. And they all have to be properly configured and working in delicious harmony together to deliver what our applications require. And then when we look to the future, a lot of the policies that we need to successfully operate this infrastructure are present in different places. The compute policy is the only one. The only policy that's actually right next to the applications themselves is the compute policy. That's the resource pool priorities that we set. The storage policy, the security policy, the networking policy are all way down in the stack attached to infrastructure components. So they're not attached to the application. And when we look to a future where the data center boundaries become fuzzier, where we may want workloads running here today and elsewhere the next, we need to change where those policies are attached. If my storage policy isn't attached to my VM next to the application, how can I be assured that it will get what it needs if it runs elsewhere? So we talked about the complexity, we talked about reliability. We talked about total cost. So this is what the new model looks like. We pull the storage up out of monolithic arrays, put it into the compute, so the compute and the data become proximate, which is there's a tremendous amount of value there. We can pull the security policy up out of there through NSX, and look at what happens. Now all of a sudden, we have a single policy management location for all of the things required to make our applications perform and operate as is necessary today. We also tremendously simplify the infrastructure. All we're doing, all that ties these things together is 10 gig Ethernet. Coming out of the back of every one of these compute nodes, 2 power plugs, 2 10 gig Ethernets. That's it. Dramatically simplified infrastructure. And then, we don't have time to dive into the networking stuff today. But one of the other things that happens is once we abstract all this, all our networking does is switch packets, which means we can choose from more vendors than we may be today. And if a 10 gig port is a 10 gig port is a 10 gig port, there's half a dozen vendors to choose from with dramatically different price points per port that can deliver further capital savings to our infrastructure in the long run. And then so in net, we get a CapEx reduction on the order of 30 to 40%, can be a little more in some circumstances. We get a substantial OpEx reduction as well. I mean, think about this just intuitively. What happens if you get rid of LUNs? How many people in your organization, how many people administer storage? Yeah, okay. How much of your life is spent messing with LUNs and making sure that the LUNs deliver what the applications demand of them, and how much micromanagement goes into managing groups of spindles and groups of flash? That all goes away in this model, which means you can focus on the more important things, which is the policy configuration of our VMs and making sure that they're getting the resources they need to meet the needs of the applications that sit on top of them. So let's talk a little bit about Lancaster General. So Lancaster General is a $1 billion healthcare system, 750 beds, 3 hospitals, 30 ambulatory practices, and they use Epic for inpatient and ambulatory. And they came to us. I have a timeline I'll walk through with you. But they came to us with challenges that you all have in common, and that's the persistent storage expansion that had both a high capex and a high operating cost. And they came to us looking for a better way to manage their environment. And what we delivered to them is a software-defined environment enabled by vSAN that now runs more than 850 VMs, 700 terabytes of raw storage. And it's been in operation since 2015, and they're running Epic 2015 on it right now for essentially everything except cache and clarity. And this resulted in a huge savings for them in upfront capital. Michael Feld in his 2 o'clock presentation, for those of you who are in that, talked about the significant capital steps required to do expansion with current monolithic storage, right? To the tune of 250K, 500K chunks. This gets us into a much more linear expansion that looks more like 40 to 60K per all-flash compute node, including the software. So as
limited a number of EMC VMAX systems.
So we talk a little bit there. I got some good story to tell on the performance front that dovetails nicely into that. Reduce complexity, obviously, we mentioned that. We get rid of the fiber channel and the monolithic shared storage, which has become a big challenge for so many of us. And the other thing that happens is I'll talk a little bit more about performance in a second, but one of the things that happens by the nature, go back to this slide, by nature of this scale-out architecture, particularly when we go to all-flash, which is the only thing that I would recommend anybody do for anything but image repositories that tend to be larger and slower. For your standard operating workloads, I would encourage everybody to do all-flash. And when you do this, you're getting 100, depending on the technologies you choose, you're getting 100 to 130,000 raw IOPS out of every single one of these nodes. And every time you add a new node, you get another 100 to 130K IOPS per node, which means all of those classic ceilings that we've run into historically that have led to those giant capital steps to the tune of 250K, 500K to get new heads is driven by the need for more IOPS and the limitations of the monolithic architecture. This addresses one of the fundamental challenges of scaling out. So this is the Lancaster General Timeline. We started talking to them about vSAN when it was still pretty much brand new. For those of you who remember, VMware 2013 was when we announced vSAN, and we actually had it as a shipping product at the beginning of 2014. So we began talking about it almost initially. And in the summer, they had a compelling event for a storage expansion that was bigger than they wanted it to be. And a compute refresh not too long after. Within the next 6 to 9 months, there was another compute refresh. So we took all of those things together and said, what could we do with those same funds? And I'll walk you through the numbers in a moment here, because they're important as part of this. And then in the spring of 2015, did their initial deployment, and by the summer they were up and running, moving test and dev workloads, and they migrated a data warehouse workload to this environment, and the DBA noted immediately that there was a change. And now you may be thinking, well, what was that change? And well, the change was that it was performing better than it had been. It was loading its data faster, and its reports were running faster than it was in its previous location. So one of the interesting things that happens to people when they do this platform transformation, particularly now, and this was not all flash because they did it so long ago, but it's especially true when you go all flash. This becomes the highest performing cluster in people's environments. It becomes a desirable place to operate, because it delivers better outcomes than the stack you have already, in production. And then in fall of last year, they began deploying their pre-production workloads for Epic 2015, and they went live this spring with a successful go live on this platform. Now, I was asked not to share the specific numbers, so I'm talking in percentage terms. So as part of helping them figure out what the right way forward was, we took a look at their baseline cost for business as usual, which was the storage and compute expansion events that were imminent. And then we took a look at what that would be with the same compute vendor that they were using, with local storage and vSAN. And it was 40% less. Now, we're just talking about capital here again. We're simplified the numbers because these are easy to assemble. And then just for fun, we looked at a less premium, more budget compute vendor and noticed even more profound savings. So this is one of the things that Michael Feld mentioned in his 2 o'clock session. It's really important to take these numbers, to assemble these numbers and make sure that they're good numbers when you take them to leadership, because this is a complete transformation of both storage and compute. There's very few people who can slot vSAN into an existing environment because, right, how many of you are blades? How many of you are just too lazy to put your hands up and are really blades? So since blades became the dominant compute model, we can't normally slot vSAN in. And if we have older compute, we might not have the right controllers, et cetera. So generally what we're talking about is a total infrastructure overhaul required to make this transition. So taking these numbers up to executive leadership is very important. So one way to look at that is the total. The other way that I think is especially compelling is to look at this on a per VM basis. Do the total and then divide by the number of VMs that you're likely to get out of that infrastructure, and take a look at what those numbers look like. So this is an example of what that looks like when you do that. So business as usual, $2,000 a VM in capital. Option 2 with same compute vendor and vSAN, $1,160, budget compute vendor, $710. So and then we talk about maybe adding capabilities as part of this transformation. Leveraging the savings afforded by vSAN and adding capabilities like microsegmentation. So in this particular example, going from $2,000 a workload to $1,400 a workload and adding microsegmentation in the process, that's value. That's a lot of value that we can deliver to our organization, because there's no ROI for risk mitigation. I can't ever make a financial case for investing in better security. But I can sure make the case that you're paying $2,000 a VM now. What if we took it to $1,360 and helped you mitigate some of your security risk? There's a really compelling argument there that we're finding resonates with executives in healthcare today. I'm going to skip this next slide and close with this, so we have good time for Q&A because we have some great resources in the room, and I promise to stick around if we don't get to all the public questions. We can talk one-on-one. Getting started. For all of you who are looking for the right opportunity to get the software-defined data center, this healthcare application platform, into your environment, first thing I would suggest, look at the planned capital outlays for storage and compute for the next 24 months. Those are great opportunities to make better use of capital that's going to be spent no matter what. And we can effect this transformation within existing budgets if we approach it that way. Small hospitals and clinics, 2-node robo with vSAN can deliver the highest performing, low cost, high availability platform on the market today, period, bar none. Legacy applications, an interesting use case. A lot of people who've gone through EMR transformations had an expectation that they would be able to decommission a lot of legacy applications. And how many of you have decommissioned all your legacy applications? Legacy applications present some interesting challenges. They present security risks and costs. We can address them both with this platform. Let's move them on to a lower cost environment and wrap them in a nice protective layer of security. For Windows 2003, Windows 2000 boxes that we can't get rid of, we can create a simple policy that blocks access to system level ports that zero-day exploits would attack. One policy for all of those VMs. Easy to write. Mergers and acquisitions. Mergers and acquisitions is the nature of healthcare right now. If you're not acquiring, you're trying to make yourself attractive to being acquired. And there's a lot of uncertainty in mergers and acquisitions, both on the security and cost fronts. And this, we talk about scaling out in 40 to 60K chunks. If we do the math incorrectly and we find we're short on resources, resolving that problem is much less painful under this scale out model. And we can define very powerful, very flexible security policies in the process. Clinical workspace, we talked about that. There is not a lower cost way to do end user computing, and specifically in the Epic context, Hyperspace delivery, than using software-defined storage. Recovery site platforms, I know way too many customers whose disaster recovery plans involve too much hope and not enough actual infrastructure. This is without a doubt the lowest total cost recovery site platform you can build. And then management clusters, to me, is a no-brainer if you guys want to get started. If you think back to the dawn of virtualization, what were the first things we virtualized? Internal IT stuff that no one would complain about, so that we could become comfortable and trust the new platform. And that opportunity still exists today. So thank you very much. I really appreciate your time today. Couple closing comments. The work we do in healthcare really does matter. The platform that we provide for the applications to run on has an impact on care. And this is a way for all of us to improve the quality of the operation of those applications, improve the quality of care for the patients of our organizations, and improve the quality of lives for us as technical professionals by providing a platform that allows us to do more efficient work. Thank you very much. Any questions? Yeah?
Do you know if Lancaster, when they were evaluating their environment, were they on Epic already, or was that their first implementation?
Yeah, you want to answer, Michael? Go ahead.
Yes, we were on Epic already. We adopted Epic 8 years ago. Okay. Something like that. Yes.
How quickly did you migrate the database users?
We didn't migrate cache.
Yeah.
But over the period you saw there, in a matter of months after initial testing, the non-cache pieces were on that. VDI components have been on that almost from the beginning.
Yeah.
This platform's delivering. A lot of SQL applications are on that, and some other, if I remember right, some Oracle pieces are on that as well.
Yeah, the cache, you're still P-series for cache today. So that's another thing to consider. For all of you who are still a non-x86 platform for cache, first step towards preparing for this is virtualizing cache, and there's a pretty compelling financial argument to be made in favor of that, both in capital and operating dollars. Yeah.
Do you have any SQL virtualization
and once again, I've got to make a qualifying statement here. I am no longer the rent-a-CTO of LGH. I still work with them on a regular basis, but they have their own staff now to do that. But when we were looking at this, we migrated, I think, a number of SQL applications use SQL Always On technology layered on top of this.
So that's the struggle that we're running into. Is we have quite a few SQL clusters, shared SQL clusters that are virtual.
Yeah.
It's trying to figure out what to do with those.
We've done that in another institution, which Jonathan mentioned, basically all of our SQL clusters have been migrated, including Oracle RAC separately onto this very platform.
The problem I'm facing is how do you tell the customer to spend $10,000 per core for enterprise? That's my issue.
Oh, so that's been a challenge for a long time, and so there's two ways to approach it. You can use DRS Affinity to relegate those workloads to a finite number of sockets and license those, or you can but that requires you to do quite a lot of work on your end with something like Log Insight, so you can prove that those workloads only ran on those sockets. That's true for both Oracle and SQL, or build a dedicated database cluster where all the sockets are licensed and you don't have to do that tracking.
The other thing we did is, if you're the size of LGH or Bay State or some of the other institutions where we work in, you probably have a Microsoft EA agreement of north of $1 million a year for a 3-year cycle. If you carefully negotiate that properly and you understand what Microsoft is doing and what products are interesting to them, you can get concessions. We got concessions at LGH from Microsoft, not for this particular topic, because it didn't exist at that time, but a similar issue with VDI. So you don't necessarily have to go through that with and pay the outrageous core charges.
Anyone else? Yeah.
So in one of the slides we saw the size of the cache database was 700 terabytes.
Raw.
No, that was not the cache size. That was the total raw size of the software-defined storage
Cache
cluster.
is about 350 terabytes. No, it's I'm sorry, it's less than that. It's about 100 terabytes. I think the total cache environment at LGH is about 100 terabytes split into 2 or 3 environments. I think, between 2 data centers. I don't remember the exact data here.
So when you say 2 data centers, 2 instances,
Keep in mind, cache is not something we can run on this today. So cache is out of scope. We're talking about all of the other systems.
Yeah, the plan here with this, I was one of the guys who did the design on this with Jonathan's folks. The plan here is to build the necessary infrastructure to eventually go off of AIX for cache onto Red Hat and then migrate it into here.
let me understand this. When you say cache is out of scope, what do you mean?
Cache still needs shared storage, as per Epic's recommendations.
So all these presentation is only for non-cache.
Yes, correct.
Yes, correct. So at LGH, the only things that are not on this, and actually let me step back. At LGH, there's 2 environments. There's the AIX shared storage ENC environment over here, and then there's this environment over here. On this environment, we put the Epic components that are not the database, not non-cache. These are the web engines, VDI pieces, all of those kind of things. Exchange is on there. SharePoint is on there. At LGH, all of our applications that have AIX as a foundation for them require that we maintain our shared storage. But we're going through each one of those, and for example, Lawson is a product that we have that can run on Red Hat or on AIX. Obviously, our plan is to move it to Red Hat. But the key was to build this environment. As John said, we were faced with a point where we had a natural occurrence because of an Epic upgrade to have to buy all this new equipment. What we decided to do was kind of buy what the least amount was on the AIX side and begin a process to build this new infrastructure that we know normally over a period of time would put everything on. Does that make sense?
You had a question down here.
So in the VSAN space, are we doing storage-based encryption now, or are you using SED?
That's a good question. So it is. We're getting into a little bit of the futures here. So SEDs pose some interesting challenges, and I realize encryption. Encryption today is not part of VSAN, and that's an interesting limitation for healthcare. What's interesting to me, though, is there's not a universal feeling about the need for storage encryption in healthcare. I have customers who won't entertain anything that doesn't do it, and I have customers who have decided it doesn't actually address enough of a need to justify the investment. That said, SEDs pose an interesting problem because there's no consistent way that that the technology is being implemented and the key management is being done. And we've kind of backed away from it a little bit because of those challenges. And if you consider the broader trend of capabilities moving up into software and out of hardware, I think that's the sensible choice. We do have encryption on the roadmap, and I'm sure there will be sessions. I don't really want to speak to it in this session, but there will be VSAN sessions that will talk about the roadmap and futures that will talk about that. And we're going to allow standard third-party key management providers like the one that HighTrust provides, and there's another one, to do the key management, and we will have it as part of this platform next year.
And that, by the way, is how another institution, Bay State, will be in implementing that.
Yeah.
You mentioned the VDI workload. How do you guys manage that, and how large is it?
I'm trying to remember here. I think the total number of sessions at LGH for VDI is somewhere between 3,000 and 4,000 concurrent ones, somewhere in that number. The vast majority being Hyperspace. There's some non-clinical ones that are there too. A combination of products additional to Horizon are what are the two products?
Res.
Unidesk and Res. Res manages the shared storage for VDI. I am not aware, correct me if I'm wrong, John, I'm not aware of any real change in our operations of storage management because that's done largely by these other programs. VSAN just simply operates mainly in the background.
LGH is not actually using VSAN for Horizon.
We haven't put that there yet?
I don't think so. Kevin? Yeah, not yet. So, because LGH's hyperspace delivery with Horizon was done before we had VSAN. And so they're just using local flash in Blades and using the local repositories and letting Horizon do the management of the replicas and that. But we have tons of customers now using HyperConverged. We have a ton of VxRail going out the door to support that, and almost everybody is doing Horizon on software-defined platform because of the substantial cost savings.
Actually, no, you're right, and I apologize. When we started the VDI project there, it was on the UCS C series.
Yeah.
And for that reason, we used Unidesk and EMC Unidesk and Res as the necessary way to do this with our fiber channel conversion. But at Bay State, it's now on a VSAN platform.
Yeah.
Would you put VDI and packet on the same flash?
So you're asking, would I combine the environment to support server workloads and the environment to combine end-user computing? So generally, no. And there's a couple reasons for that. One is licensing, because when you buy the Horizon license, the ESX necessary to deliver those sessions is included. So that's one reason to separate it. The other reason is there are some significant differences between end-user computing workloads and standard server workloads. On this. Well, so when we talk about hyperconverged architectures, there's no longer a difference. They're all the same. So my cluster using vSAN, the storage is local to that cluster. So generally, we're going to see those environments continue to be separate, and there's good reasons, economic and operational, to do so. Yeah.
That's how you get the cost per VM.
Mm-hmm.
It's like $2,000 or $1,000. What's the lifetime of that VM?
So I think that was a 3-year capital cost divided by the number of VMs.
Another question.
Yeah.
How would you approach it if a customer already has all the existing pieces of what you showed on the screen, Flash, UCSB, the whole works? How would you? Is vSAN then not as cost effective?
So as I said, it generally requires net new compute with integrated storage in order to affect this transformation. So it's not that it's less attractive. It's a question of timing. Whatever capital you already have in your environment must run out the remainder of its useful life to get the value out of that capital. There's no, even if there's savings potential to be realized, there's not generally good reasons to decommission stuff that still works. It really comes down to looking for the right time, as I said, where capital is going out the door for refresh. And that's something to consider. Everybody has a 3 to 5 year infrastructure refresh cycle, which means 20 to 30% of everybody's environment is turning over on an annual basis. So there are always opportunities to hook in to that capital purchase cycle to begin this transformation.
Especially in an epic environment, because your hardware is going to fall off there even sooner.
That does happen. Go ahead.
You can also, with VSAN, you do have an option to have a JBOD type thing that you can attach to existing blades, right? And maybe we'll provide storage versus the current blade.
I'm just mentioning that we bought VMware, so the investment is already made.
Yeah, the investment is made, and you guys are going to enjoy your very expensive infrastructure for some time. Yeah.
I was going to add something you mentioned about running Horizon on VSAN. My previous employer, Lancaster General, we ran about 560 or so virtual desktops on VSAN.
Let me kind of follow up because the better example for this architecture is what Bay State has done. Bay State, just like Lancaster General, is moving. They're not an Epic shop; they're a Cerner shop, but they're moving all of their non-critical AIX type stuff to that environment. But they're just starting to do VDI, and theirs is about a 10,000 seat deployment. That will be totally on the system. And to John's point, there's literally a separate set of hosts that are the enterprise piece of this architecture, and there's another set of host cluster here, which are the VDI ones. So we never even attempted to do VDI in anything other than VSAN at a new institution.
Yeah.
I saw the comparison between the converged architecture you're proposing versus the NAS. But if you guys do a comparison of cost, if you migrate to NAS versus converged?
You mean other alternative converged platforms? Yeah, so...
Are you talking like Nutanix, stuff like that?
Yeah, we don't say the N-word.
I am a customer.
I would encourage you to do the math. I would encourage you, as part of, remember that early slide on value. Do the math with all of your platform choices and make the decision where the math makes sense. What you'll find is companies that sell hardware mark up the hardware, so it's harder to get the same value. When the person is selling the hardware and the software in a fancy wrapper, it's almost always going to cost more per workload.
One of the things that we found, we do this analysis for all the institutions, including LGH. The larger the institution, the more likely, especially if you're interested in not just storage, but full hyperconvergence, because there's many advantages, like John said, about security components. Those little prepackaged things almost never offer the level of security and networking abilities that this does. So if you go down one of those N-word, one of those vendors, and you wish to achieve some of the advantages that NSX can do, you're going to end up spending a lot more money in a much more complex system. So I would argue, kind of weigh those two together.
Anyone else? All right, we'll hang out down front if you got anything else you want to talk about. Thanks a lot, guys.